Alright, hello class. Instead of doing notes for chapter 16, we have the problems from the review that I'm going to work on, starting from 19 going all the way to number 41 for chapter 16.1 to 16.3. And we'll hopefully do the rest of them in class at some point. So, the first question we have is to find all square roots of the number. And our number is 324. If this question was not multiple choice and then we didn't have these options to see which ones work or make sense, this is how we would tackle it. I would recommend to look at the last digit. And you want to think of things that multiply together to get you 4. Like 2 squared is 4. But that's far too small because we want 324. So think about perfect squares that you know, like 25 squared, well, that's 625. That's way too big, right? 20 squared is 400. Okay, still too big. We'll have to work our way down. Maybe, I don't know, 12 squared. Oh, that's 144. Too small now. So we have to work where we can think of something within our range that we have going on here, 12 and 20, and we need a 4 that it ends with. Maybe we could think of another thing that's squared that gives us a 4 at the end, like 8 squared. That's 64. So there's that pattern. So because 20 was too big, I'm going to try 18. And this is just me guessing, but trying to do it in a logical manner. So let's see what 18 times 18 gets us. We know 8 times 8 gets us 64, which ends in the 4 like we wanted. 8 times 1 is 8, plus the 6 is 14, placeholder. 1 times 8, 1 times 1, add them up. 4 plus 8 is 12, carry the 1, and sure enough, there it is. So remember, we're finding all square roots. So positive 18 times positive 18 gets us 324. The same deal applies for negative 18 times negative 18, because a negative times a negative is a positive, and we already did 18 times 18 was 324. So our answer is choice C. Not too bad. Let's see the next one. We are asked to simplify the square root of 169. Now, since the directions are simplify, it's only asking us for the principal or the negative root, depending on what's in front of the radical. Since there's no sign in front of here, it's actually positive, this one is asking for the principal square root. And sure enough, 13 squared is 169, so the principal square root is 13. Now, 21 has a negative out front. So when we find our square root, we want the negative one. So 49, well, 7 squared is 49. Since the negative is out front, they want negative 7. Alright, now you might be getting a little worried about that not a real number option. Let's see, well, let me cheat real quick, and I'm going to skip the previous question, and I'm going to talk about that option when it's not a real answer. And we have to decide whether or not the radical expression represents a real number. So that is completely dependent on the radicand. So you look at the radicand. If the radicand's positive, then it works. If the radicand is negative, then it doesn't. So our radicand, it's what's under the radical. We have 196. Yes, it's positive, so it is a real number. It's kind of a bad question because it says or, whether or not. So we want to say yes it is, but you kind of get what we're meaning. The next one, 24. Look at the radicand. 16. He's positive, so our answer is yes. Sure, there's a negative hiding out in the front, but that doesn't make a difference to us. All we're concerned about is the radicand. Same deal for number 25. We have a negative times a negative inside the radicand. Well, that makes them both positive. So we have a positive radicand, so our answer is yes. Finally, something a little bit different. We have negative 135 for the radicand. It's a negative number, so it does not work. Let's go back to our previous question now, 22. It says identify the radicand. The radicand is the thing that's under the radical symbol. So here's our radical symbol. Whatever's underneath that, that's our radicand. So 3 over x plus 4. Choice B. This guy's silly because the radical's there. We don't have a radical in a radical. The radicand is the piece that is under the radical. And this is on the outside. Crazy talk. I don't even know what's going on there. Okay? Alright. Next, we have simplify. And this little disclaimer here is our safety net saying everything's positive. Don't worry about the radicand being negative. And the reason why we do that is because we don't want to think about that z potentially making things negative, and then we can't take the square root. So we have the square root of something squared, in which we have a rule that states if we take the square root of anything squared, it's just that anything. So we have z minus 5 squared, and we're taking the square root of it. Pretty much the square root cancels out the squared, and we're left with z minus 5. Fairly nice. Now 28, not as nice. We got a little bit of work to do. We have a polynomial underneath the radical. So that means our first step whenever we have a polynomial is to factor. And generally you can kind of predict these guys are going to be nice. They are perfect squares. There's a 36, which is 6 squared. 12 is 6 times 2. So this is going to factor perfectly to z plus 6, that quantity squared. Now that's only the radicand. This is still under the radical. So we have the square root of something squared. Same deal, goes back to our rule. So we're just left with z plus 6. And these absolute values and crazy stuff going on here, I have no idea. We could eliminate those. We've never talked about absolute values, so they make no sense. And this one is just if you forgot your square root, right? We need to take the square root of this, so he's nonsense as well. So D is the only right answer. Alright, continuing on, we're going to simplify the radicals. We have the square root of 175 y squared. So 175 is not a perfect square, but we can find things that can go into it. So we're going to make our prime factorization tree whenever we don't have a perfect square, in hopes that we can pull out a perfect square. Since this number ends in a 5, I know 5 can go into it. And 5 can go into 17 3 times. You got a 2, bring down the 5. 5 times 5 gets us 25. 35 has 5 and 7. So there's our prime factorization. Now, in order to leave the radical, you need a buddy system, so you group up. Here's 2 together, so they get to leave the radical, so he comes out as 1. 7 didn't have a buddy, so he's stuck under the radical. Y squared is really y times y, so he has a buddy. And we even said the square root of something squared is just that something. So we have 5y square root 7. And the only one that gets us that is choice A. Alright, now I'm going to erase this part here so I can have a little bit more work. And we're going to work on number 30. We have negative square root 90. Now, the negative is on the outside. So he's just chilling on the outside. If you want to think of it, it's negative 1 times square root 90. So he's just on the outside. He has nothing to do with our radical. So looking at only the radical part, we have the square root of 90. And 90 is not a perfect square, so we're going to break it down. So 9 and 10. 9 has 3 and 3. 10 has 2 and 5. So there's our prime numbers. And now in order for us to leave the radical, we need a buddy. Alright, so 2 3's pair up. And 2 and 5 don't have any buddies, so they're stuck under the radical. Now here comes the cool part. That's negative 1 times this thing. So we have negative 1 times, a 3 comes out, times, and the 2 and the 5 are left under the radical, so we'll multiply them together. And let's see, oh, that undid everything. Redo it. Let me just erase it. I wrote a 1. So we have 2 times 5 under the radical. So negative 1 times 3 is negative 3. 2 times 5 is 10. And nothing can leave because they don't have a buddy. So that's it. That's our answer, which is choice D. Alright, last but not least, we have the square root of 225, m to the 17th, n to the 4th. Now, if you know your perfect squares, 225 is a perfect square, and you can kind of see almost in the multiple choice, they're all saying 15, and that is in fact 15. So 15 gets to leave, right? We had two 15s essentially. And now m to the 17th. When we have exponents, we pretty much agreed in class that we'll divide by 2. So we'll take 17, and I'm just going to scoot off to the side here, and we're going to divide 2 into it. So 2 times, well, 8's the closest we'll get. We got 16, remainder 1. So that means 8 m's are going to come out. That means 8 m's get to partner up, and we have a remainder of one of them left behind. And we'll do the same thing for n to the 4th, which is a little bit easier to write out. We have 4 n's. These guys buddy up. Sure enough, 4 divided by 2 gets us 2 groups who come out. And that's it. That's our answer. So now we just got to pick which one's right. This guy almost tricked me, but that's a 7 there. We need an 8, so choice C is our answer. Alright. Moving right along, we'll head into multiply and then, if possible, simplify. So we have the square root 3 times the square root 18. So there's several ways you can tackle this. You can simplify in advance, or you can multiply then simplify. The direction said multiply then simplify. I think we'll go ahead and follow their way. So we have a rule that says the square root of a times the square root of b equals the square root a times b. So underneath our radical, we have 3 times 18. Now you can multiply that together. I'm guessing it's probably 54, but I don't know. I'm not really going to bother, because when I have a number that's not a perfect square, I find the prime factorization. So 3's prime, 18 breaks into 3 and 6. 6 breaks down into 2 and 3. So there's all my prime numbers that are under the radical, and we're going to collect groups of 2. So we got 2 3's, and that's it. So 2 and 3 are stuck under the radical. We'll multiply them together, so we have 3 root 6. And there's our answer. Alrighty, I'm going to cheat and erase this again, so if you need to pause it for a second, do so. And our next one, we have square root 5x times square root 10x. So our rule says if they're separate, being multiplied together, where they're both under radicals, right? That's the key part. It's square root a, square root b. Then we can combine them under one radical. And let's say you felt funky about 32. I'm going to show you why it didn't matter that I had to multiply 3 times 18. Let's do this one. It's easier. 5 times 10 is 50. And x times x is x squared. Now 50, I'm going to find its prime factorization. Oh, I'm going to break it down into 5 and 10. Okay, 5's prime, 10 will break down to 5 and 2. And it doesn't make a difference because I have to break it down into its prime numbers anyways. So that means a 5 is going to come out because we have buddy system. Pops out. 2 doesn't have a buddy, so they're left behind. X squared is really x times x, so there's their buddy. Sure enough, 2 divided by 2 is 1, so 1 is left. And our answer is choice D. Alrighty, so let's continue on. 34 is probably my all-time favorite, and I seem to always put it on every single test each semester. I can't help myself. So let's go ahead and tackle this one. We have square root rs times square root st. So we'll multiply them together, all under one radical. We have r times s is s squared, and times t. Now r doesn't have a buddy, so he's stuck under the radical. T doesn't have a buddy, he's stuck under the radical. But s has, buddy, so he gets to leave. So our answer is s square root rt, which is choice A. And last but not least is number 35. Now 35 is a rule. It kind of expands off our product rule, in which if we have the square root of a times the square root of a, we can put it under one radical. We have the square root of a times a, which is really the square root of a squared. And we saw this rule earlier, that is just a. So, if I have the same radical times itself, it's just the radicand. So square root x minus 9 times square root x minus 9, same radicand. The answer will just be the radicand. Pretty cool, huh? Alright, let's continue on. We're on a pretty good roll. So, we're going to divide and simplify. We have the square root 2 all over square root 72. So it's important for us to know our rule, in which we have the square root of a over the square root b is equal to the square root, and I'm not sure if my screen's cutting off that square root, a over b. So we can put them under one radical. So we have square root 2 over square root 72. The main thing we always are looking out for are perfect squares, especially if we see them. That's nice. So I don't really see anything. I'll go ahead and combine them. Now, can 2 go into 72? Sure can. In fact, it goes into it 36 times. So we have the square root of 1 over 36, in which we can break up into the square root of 1 over the square root of 36. Why? Well, 1's a perfect square, and 36 is a perfect square. So my answer comes out fairly nice. Okay. Let's take a look at 37. Now, I'd hate to show you how I do it, because so many of you come up with much better ways. I sometimes take the long way around. I would say attempt to do this one on your own and just check your answer. But I'll go ahead and show you how I do it. I see the 144 is a perfect square, and I want to simplify it. I know x isn't, but he'll just stay where he is. So square root of 144 is 12, but I still have square root x, can't do anything about it. The square root of 4x, well, x doesn't have a partner, I still have square root x, but the square root of 4 is 2. Now I simplify. Notice we have the same thing over the same thing. That's 1, cancels out. So we're left with 12 over 2, which is 6. So however you do it, go for it. Many different ways you can tackle that one. Alright, last but not least, we have 38, in which we have to simplify. Now, you might be thinking, oh, well, 22 and 10, their guys are perfect squares. Yeah, but 5 and 20 aren't, so I'm going to go ahead and combine them, just to make it look a little bit cleaner, I hope, at least. So, when I put them all under one radical, now I got to simplify. Now, 5 can go into 20, that reduces to 1/4. And I'm cheating where I'm just going to write 4, because 1 up top, 1 times anything is still the same thing. And I can see that t to the 22nd over t to the 10th, well, we subtract the exponent, 22 minus 10 is t to the 12th. And he stays in the numerator because the bigger exponent was up there. Just like how the bigger number was in the bottom, so we went to the bottom. Always follow gravity. The bigger guy, right? So now let's see if we can reduce this. Well, sure enough, we have perfect squares. We can take the square root of t to the 12th over the square root of 4, which gives us t to the 6 over 2. And that's choice B. Alrighty, last but not least, let's go ahead and tackle rationalizing the denominator and simplify. So, the first one. We can't simplify much further here. If you're able to, you should try, but 23 is not in a radical, so we can't mess with the square root of 23 because they're not the same thing. But we do want to rationalize. That means we don't like square roots in the bottom. So in order to get rid of this 23, I'm going to multiply top and bottom by root 23. Now square root 23 times square root 23, that goes back to our rule in which the square root of a times the square root of a is just a. So square root 23 times square root 23 is just 23. Now up top we have 23 times square root 23. This guy is not in a radical, so he can't combine together. It's just 23 times square root 23. Can't do much else about it. But if we're able to, we should simplify. And you might go ahead and see that we have 23 over 23 which cancels out. We're left with 1 times 23. I'm sorry, square root 23. So our answer is just square root 23. Fairly cool answer. Now, that might not have been very satisfying, so let's go ahead and do number 40, in which when we look at this guy, you might be noticing that 16, which can simplify. It's actually the square root of 16 is 4, and we have the square root of 5. Now, we still have that square root in the bottom. We don't like him, so we'll multiply both top and bottom by square root 5. Root 5 times root 5 is 5. 4 times root 5, well, since 4 is not in a radical, we can't combine them, so it's just 4 times root 5. And I'm sorry about my box, got a little crazy. So our answer is choice A. So here's a rule to remember. Square root A times square root B equals the square root A times B. These guys are both under radicals, so we can combine them. But if we have a constant times a radical, there's no way we can combine them. It's just the constant next door to the radical. Alrighty. Last but not least, let's see number 41. I'm going to go ahead and extend the page if I can. Okay. And this one is interesting. Now, together, they're not too pretty. Let's see if we can split it up, both top and bottom. Now, the square root of 98 is not a perfect square, but maybe I could simplify it. And you might be cheating looking at your multiple choice and you see, yeah, it looks like they did some simplifying there. 7 looks like it came out, right? So let's see if we can simplify it. I'm going to go off to the side and just work with that square root 98. Then I'll worry about rationalizing the denominator. I like to take little bites. So, 98. Nothing's jumping to my mind right away. It ends in an 8, so I know 2 can go into it. 2 times 4 is the closest we'll get to 9. That's 8. Subtract, you got an 18. 2 times 9 is the closest we get to 18, so we got 49. Alright, so 2's prime. Ooh, 49. That's a nice guy. In fact, it's a perfect square. And you could kind of almost see that was going to happen, right? So this simplifies to 7, comes out because he had a buddy. 2 didn't have a buddy, so he's stuck under the radical, over square root x still. Now we still have issue where we don't like that square root x in the bottom. So we want to undo it. We want to get rid of it. So we'll multiply both top and bottom by square root x. Alright, let's do the bottom first. Square root x times square root x is just x. Now up top here, we got a little bit going on. We have 7 times root 2 times root x. I'm going to scroll up a little bit. Now, 7's a constant, and there's radicals, so he's just going to stay by himself. But root 2 times root x, they're both under a radical. That means we can combine them. So we have the square root 2x, all under one radical. So there is our answer. Now I got to find it. Choice C. And that's it for 16.3. Monday we're going to go over the 16.4 and so forth. So we'll finish up the last bit and our test is Thursday. So until the next time,